everyone, I'm Kelly Gallagher, and we're here at IMTS 2024 to show you how digital manufacturing helps empower companies to use technologies like AI, CNC machining, generative design, 3D printing, human simulation, and more. In the next stage, we learn how to design and build the component using NX additive manufacturing software. Let's talk to our additive experts to learn more.
My name is James Heckendorn. I'm going to be taking you guys through the design and build simulation side of things today. Once we get our data from engineering and we validated kind of our analysis, we'll move into the generative design and design for additive portion of the workflow today. So at this stage, right, we've got our part design data and we're going to move into utilizing topology optimization to allow the computer to inform us on the best design based on our loading conditions, our design space, and what our part is going to experience. Here inside of NX, we're going to set up all of that condition and we're going to use our embedded topology optimization that's associative to the rest of our design process so that we can capture the best additive design based on our initial conditions. From here, we're going to use that integrated associative environment to capture that additive design intent. And then again, that output is going to be what we call mixed convergent geometry, where it's a combination of mesh and true analytical data that we can utilize throughout our existing design process. We can apply that manufacturing information and all of that other data that we're going to get in terms of the rest of our design process. Once we've arrived at our finalized design, we move over into the manufacturing planning and simulation side of additive manufacturing. Inside of here, we're going to set up and optimize our parts design for printing. We're going to generate supports, and we're going to lay out that series of parts on our build plate. Inside of this video here, we've arrived at that optimized orientation with supports. And from here, we're going to move on into analyzing how that actually gets built on the machine. And so this uses a kind of combination of the machine and the material, as well as the design orientation, to simulate and analyze how that part gets built additively on that specific machine. Once we get to that portion and we get the results of that simulation, we can look at the predicted distortion. We can analyze if there's going to be any specific manufacturability issues at play and account for that in our design process, and then look at and also get compensated geometry out of that part so that we can get to that first time right print as quickly as possible. Here in the design phase, this is where we use all of these different additive tools like we covered in topology optimization and our convergent mixed modeling, as well as our setup and simulation tools to arrive at that first time right print so that you guys as the customer can have confidence in that additive design. So at this point, we've arrived at a design that, again, satisfies our design constraints. We have confidence in the way it's going to be printed out on a machine. This is where we move over into the planning and setup side of things over here in our part manufacturing end-to-end solution.